Lesson 1, Matter and Measurement. Chemistry is the study of matter and the changes it undergoes. Matter can undergo either chemical or physical changes. The key part of this system is observation. Observations are the facts of science. From observations come the regularities and patterns that we use to come up with hypotheses to test by more experiments, which are controlled observations. Repeated observations that confirm a hypothesis lead to a theory that explains more and covers more than a hypothesis. Both hypotheses and theories can be disproven by further observations and are changed when this happens. Scientific laws are the underlying principles that are discovered by repeated observations and are deeper explanations of those observations. This is the definition of matter. All matter is made of atoms, which can appear as single atoms or groups of atoms. Elements can be single atoms or groups of atoms that are identical. Compounds are groups of atoms that contain different elements. Physical changes are changes that change the physical state of matter without changing the arrangement of the atoms. The three common physical states are solids, liquids, and gases. This is a classification tree for deciding what kind of matter you have. Is the matter uniform throughout? Non-uniform matter is called heterogeneous and is almost always a mixture. Uniform matter is homogeneous and may be a mixture or a substance. Does it have a variable composition? Homogeneous matter with a variable composition is a mixture and is called a solution. If it has a constant composition, it is a substance. Can it be separated into simpler substances? If a substance cannot be broken down into simpler substances, then it is an element. If it can be broken down, then it is a compound. Nickel is a silvery metal. Hydrochloric acid, a colorless solution. When we mix nickel and hydrochloric acid, the two substances combine and produce another substance with very different properties from either of the substances we started with. This is a chemical change. Properties and changes of matter. Types of properties can be separated into two different ways. We can separate them into physical properties, which keep the substances the same, some examples of which are boiling point, density, mass, and volume, and chemical properties. Which change the substances. Some examples are flammability, corrosiveness, reactivity with acids, and so forth. Alternatively, we can separate them into intensive properties, which do not depend on how much of the matter we have. Some examples are density, boiling point, color, and extensive properties, which do depend on how much matter is present. Some examples: mass, volume, energy. All chemical properties are intensive. Some physical properties are intensive and some are extensive. Physical changes do not change the substances that are present, meaning that the very same molecules are present after the change. Things like changing state, changing temperature, changing volume, and so forth. Chemical changes do change the substances present, which means we have new substances present after the change. Combustion, oxidation, decomposition, and so forth. During a chemical reaction, we have a chemical change. In fact, a chemical change is a chemical reaction. Compounds are only broken down by a chemical reaction. Mixtures, on the other hand, can be separated by physical changes. Several examples are distillation. A solution is heated to vaporize a volatile component, one with a low boiling point, leaving a non-volatile component behind. The volatile component is then condensed and collected. Mixtures of several volatile components can usually be separated by fractional distillation. Filtration separates solid components from liquid components by using a piece of filter paper, which traps the solid and allows the liquid to pass through. Chromatography separates substances based on their variable solubility in a particular solvent and their attraction to some substrate. The International System of Units, otherwise known as SI, is based on the 7 defined quantities and units shown in this table. These quantities and units are defined based on measurable values of properties. All other quantities are derived from combinations of these 7 quantities. The sizes of units are changed by using a set of prefixes that show the size of a unit based on some base unit. The prefixes always mean the same thing, regardless of the base quantity to which they are attached. For example, a kilometer, or kilometer, is 1,000 meters, and a kilogram is 1,000 grams, 2 very common occurrences of the prefix with a defined SI unit. But these prefixes can be used with any unit. So a kilojoule is 1,000 joules. The joule is a unit of energy. And a kilosecond is 1,000 seconds, even though you will not usually see the unit kiloseconds. This table gives a partial listing of the possible prefixes that can be used. For the most part, each new prefix is 10 to the third away from the previous prefix. One example of a derived unit is a unit for volume, most commonly liters and milliliters in the lab. 1 liter is defined as the volume of a cube 1 decimeter on a side. Therefore, 1 liter equals 1 cubic decimeter. And 1 milliliter is defined as the volume of a cube that is 1 centimeter on a side. And 1 milliliter is therefore 1 cubic centimeter. Different measuring devices have different uses and different degrees of precision. The different measuring instruments offer different precision based on how they are calibrated. There are 3 commonly used temperature scales. The Celsius scale is used in most of the world, and it and the Kelvin scale are used in science. The Celsius scale has 0 degrees as the freezing point of water and 100 degrees as the boiling point of water. The Kelvin scale, or the Kelvin is defined, the Kelvin is the defined unit of temperature. Zero kelvins, note there is no degree sign, is the lowest possible temperature, called absolute zero. And therefore, there are no negative temperatures in the Kelvin scale. The Kelvin and Celsius scales have degrees the same size, but with 0 at different places. The Fahrenheit scale is used for common temperatures in the United States, but is not used in science. The relationships between Fahrenheit and Celsius are given in these 2 equations. Density is another example of a derived quantity. It is defined as the mass of an object divided by its volume. Interestingly, density is an intensive physical property derived from 2 extensive physical properties.